Hello, this is June 2018, Variant 2, Paper 1, CIE Chemistry A-Level question paper solving. We are going to go through all of the questions. We're going to say which ones are wrong and which ones are right. We're going to explain why they're wrong and why the options are right. So number 1, which feature is present in both ethene and polyethene? So for this one, first let's draw both of the compounds. Ethene is C2H4. Polyethene is C2H4N. Ethene has a double bond. Polyethene does not have a double bond. Ethene only has 3 bond pairs, no lone pairs, so the angle is going to be 120 degree. Polyethene has 4 bond pairs, so the angle is going to be 109 degrees. Both have to have 109 degrees, so A is wrong as C2H4 has 120 degree. Single bonds only contain sigma bonds. Double bonds contain both sigma and pi bonds. So only ethene has pi bonds. Polyethene does not. So B is going to be the wrong answer. For sigma bonds, both single bonds and double bonds contain sigma bonds. So sigma bonds is going to be the right answer. As for sp3 hybrid orbitals, only the single bonds, that is polyethene, is going to have sp3 hybrid orbitals. So D is going to be wrong as well. The electronic configuration of an atom of sulfur is 1s2, 2s2, 2p6, 3s2, 3p4. First, let's draw the electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p4. I'm sorry about this. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we now have 3p4. So there is going to be 2 unpaired electrons. So the option is going to be either B or D. And we have 6 outer electrons, 4 plus 2, 6 valence shell electrons. So the option is going to be D. So the only answer possible is D. Number 3. In which pair does the second substance have a lower boiling point than the first substance? C2H6 and C2H5Cl. CCl bonds are polar. So polar bonds are going to be stronger than van der Waals forces. So C2H5Cl is going to have a higher boiling point. CH3OCH3, there are no polar molecules. C2H5OH, OH bonds are polar. So they're going to have hydrogen bonds or like dipole-dipole forces, which is going to be stronger than that in CH3OCH3. So C2H5OH is going to have a higher melting point or boiling point. Neon and argon is heavier. It has a greater atomic number, so it is going to have stronger van der Waals forces of attraction. So argon is going to have a higher boiling point. So C is the wrong answer. CD3NH2 is polar. NH2 bonds are polar. So this is going to be polar, whereas C2H6 is only going to have van der Waals forces as CH bonds are non-polar. So this is going to have a lower boiling point. So this is going to be the correct answer. Compound J burns in excess oxygen to give carbon dioxide and water only. When a 3-gram sample of compound J is burnt in excess oxygen, 4.4 grams of carbon dioxide and 1.8 grams of water are formed. So we have 4.4 grams, which is 4.4 divided by carbon dioxide is 12 plus 16 into 2. I should probably write it somewhere else. It might get a bit messy. So carbon dioxide is 4.4 divided by 12 plus 16 into 2. That's 4.4 divided by 44. You have 0.1 moles of carbon dioxide, 1.8 grams of water, which is 2 plus 16, 1.8 divided by 18, which is 0.1 moles of water. And now you can just go through all of these compounds. CH, it is 12 plus 1, 13. CHO, 12 plus 16 is 28, plus 1 is 29. CH2, 12 plus 1 into 2 is 14. CH2O, 12 plus 1 into 2 is 14, plus 16 is 30. If you compare, this is going to have 3 grams divided by 30 equals to 0.1 moles. The molar ratio is equal for all of these. 0.1 moles of carbon dioxide, 0.1 moles of CH2O burns in excess oxygen to produce 0.1 moles of carbon dioxide and 0.1 moles of water. So the formula is going to be kind of like this. CH2O plus O2 is CO2 plus H2O, where there is going to be, since carbon dioxide and water are in equal ratios, it is 1:1 ratio. So there is going to be one carbon here, two hydrogen molecules over here, so that ratio is maintained over here, and one molecule of CH2O results in, this is excess oxygen, so we can have any number of oxygen, we don't care. 1 mole of CH2O gives rise to 1 mole of carbon dioxide. 1 mole of CH2O gives rise to 1 mole of water, so these parts are balanced. And oxygen, since it's in excess, we don't really need to balance that but it's not all that important, but this satisfies our equation. Whereas if it was CH2, these are the only two options we have. Since carbon is to hydrogen ratio is going to be 1:2, CH2 is not going to be the correct answer, since it does not satisfy our molar ratio, because 3 divided by 14 is not the same as 0.1, so it does not satisfy our molar ratio. C is not going to be the answer. The only possible answer is going to be D. I could just discard it. So moving on, the gases X and Y react to form Z. So I'm going to turn screen right on again. X and Y react to form Z. X plus Y is Z. As an equilibrium mixture of these three gases is compressed at a constant temperature, what will be the change in the mole fraction of Z and in Kp? So I want to compress them. If I compress them, there are 2 moles of gases on the left-hand side and 1 mole of gas on the right-hand side. When pressure is increased, the equilibrium shifts from higher number of gases to lower number of gases. So equilibrium shifts to the right. The yield of Z is going to start increasing. So mole fraction of Z is obviously going to have to increase, whereas the Kp value will remain unchanged. The Kp value will not change because Kp only changes when temperature changes. That is the only time Kp is going to be affected. So the answer is going to be increase, so either A or B. But here the Kp is set to increase. That is not correct. B is the only one that is possible since it shows no change, so the answer is B. Which gas is likely to deviate most from ideal gas behavior? HCl, He, CH4N2. We want the one that does not follow. So what are the conditions that we need to meet? Number 1, there should be very weak intermolecular forces, weak, let's just say IM forces. Number 2, the particle needs to be small, particle needs to be negligible volume, need to have almost 0 volume, so just say 0 volume. And the others, the elastic collisions and stuff, that is not something that we can be concerned over here. So these are the 2 conditions that we're going to look for. So we are going to go through all of them. This one, HCl, it has a very high difference in electronegativity. So this is going to form very strong intermolecular force of attraction. Helium is nonpolar, it's monatomic, it is a very good ideal gas. CH4, nonpolar, has very weak intermolecular forces. Nitrogen, nonpolar, very weak intermolecular forces. So all 3 of these have weak intermolecular forces. The only one that has a strong intermolecular force is HCl, which is why it is not going to behave at all like an ideal gas. So the answer is going to be A. Number 7, the enthalpy change of reaction 1 is minus 114 kilojoules per mole. 2NaOH plus H2SO4 is Na2SO4 plus 2H2O. By using this information, what is the most likely value for the enthalpy change of reaction 2? Barium hydroxide plus 2-hydrochloric acid is barium chloride plus water. The enthalpy change of reaction 1 is minus 114. So we have to use this information to find what is the most likely value for the enthalpy change of reaction 2. So for this one, we have to understand that this is an example of neutralization reaction. So alkali is reacting with an acid to form salt and water. The same thing is happening over here. An alkali is reacting with 2 moles of acid to produce salt and water. 2 moles of water is being formed. For neutralization, the condition is that 1 mole of water must be formed. I hate this. All right. 1 mole of water must be formed. So when 1 mole of water is formed, since 2 moles of water is formed here, the enthalpy change is minus 114. So if 1 mole of water is formed, the enthalpy change will be minus 57. Since 2 moles of water is being formed in both of these equations, So the answer should be C, because they both produce the same number of moles of water, and if the same number of moles of water is formed, the neutralization value should be the same for all reactions, as long as they're strong acids and strong bases. Number 8, sulfur reacts with concentrated nitric acid in a redox reaction. Sulfur plus nitric acid is sulfur dioxide plus nitrogen dioxide plus water. What are the changes in oxidation number of sulfur and nitrogen in this reaction? So sulfur is alone. Whenever something is alone, it has to be 0. Sulfur dioxide, oxygen has -2 charge. So oxygen, there are 2 oxygen molecules here, so it is -4. So in order to balance this out, we are going to need +4 for sulfur. So the number has increased from 0 to +4. So the answer is either going to be C or D. Moving on to nitrogen. Nitrogen, there are 3 oxygen molecules here, so -6. There is 1 hydrogen, so that's +1. +1 minus 6 is -5 overall. In order to balance that out, you need +5. So nitrogen is +5 over here. For nitrogen over here, once again, oxygen is -2. There are 2 oxygen molecules, so nitrogen is +4. If there is any confusion, we have to write this down. Whenever someone's alone, this is 0 oxidation number. HNO3, hydrogen is always +1 unless it is reacted with a metal where it's like sodium hydride, where it becomes -1. Nitrogen is unknown. Oxygen is almost always -2, so -2 into 3. -2 into 3. So everything must be 0 since the atom is not charged, the molecule is not charged. +1 minus 6 plus x. So x is equal to 0 plus 5 equals to +5. Did I make a mistake? Yeah, it should be +5. Yeah, I'm sorry, +5. So, and for sulfur dioxide, x plus 2 into -2 is 0. So x equals to +4. This is for sulfur dioxide, the value of sulfur. And for nitrogen dioxide is the same thing. Nitrogen is +4. So for sulfur, we went from 0 to +4. And for nitrogen, we went from +5 to +4. So for sulfur, the increase has been +4. For nitrogen, the increase has been -1. Like it has decreased by 1. So the answer is going to be D. Number 9. Materials can be classified by their chemical structures. 4 common types of structures are metallic, ionic, simple molecular, and giant molecular. Some physical properties of 4 substances are shown in the table. Which substance has a simple molecular structure? So, for a simple molecular structure, it is going to be a covalently bonded compound. So, simple molecular is going to have a very low melting point. Usually, it is going to be a poor conductor of electricity in all states. And the only ones that follow these conditions are these one, poor conductors of electricity in all states. B and D, but D is not going to be the answer as this has a very high melting point, so this is giant covalent. So the only answer option available is B. This is simple covalent. This is giant. Good when solid with a high melting point, there is a good chance that this is ionic. Effects of adding water, like we don't want effects of adding water. Whenever we say that something reacts, then there is a good chance that that is metal, but it could be one of the group 1 metals probably. And group C, for that, since it's soluble in water, there is a good chance that it's an ionic compound. It is a salt, so it is probably going to be an ionic compound for C. But that is not what the question is asking, so we're not going to overcomplicate it. In a particular reversible reaction, the yield of product is increased if the temperature is increased and if the pressure is increased. Which equation could describe this reversible reaction? So temperature increased, the yield is increased when the temperature is increased. So the equation has to move to the right. So x plus y is equal to z, something like this. If the del H, when the temperature is decreased, the reaction has to move to the right since the yield of product increases. When the temperature is decreased, the reaction moves towards the exothermic direction. When the temperature is increased, the reaction moves towards the endothermic direction. So here, the temperature is increased. So when the temperature is increased, the reaction has to move to the right. So the forward direction has to be endothermic. So del H must be positive. Del H is positive. If the pressure is increased, the yield of product is increased. if the pressure is decreased, the yield of product is increased. So whenever we have something, when there are gases involved, when the pressure is decreased, the reaction moves from the side with fewer gases to the side with more gases. So in an example like this, N2 plus 3H2 is 2NH3. If you increase the pressure, the equilibrium is going to move to the right. If you decrease the pressure, the equilibrium is going to move to the left, because there are 4 moles of gases on the left side and 2 moles of gases on the right side. So when the pressure is being decreased, the equilibrium is going to move from the side with fewer gases to the side with more gases. Now, the options that are available to us, since it has to be positive, like endothermic, is A or D. The next thing that we're going to have to see is which side has more gases in the, what do you call it, in the right hand side. So this one has 3 moles of gas on the left hand side, 2 moles of gas on the right hand side, so D is out of the question. So the only option available to us, 2 moles of gas on the right hand side, 4 moles of gas on the left hand side, so the answer is going to be A. So I just answered 10 questions over here. This is just an idea of what the videos are going to be like. I don't want it to be overly long. I just want to give an idea of what things are going to, what is going to come, so that I can get some constructive feedback as to what the video was like. If there's anything that I could add to the video, if there was anything that, you know, would make it a better process for you to understand, please do let me know in the comment sections, because that is going to help me immensely. And any forms of suggestions, anything that you'd particularly want me to do, I will be happy to do it, as long as it is within my capacities, of course. So please do share it if you think that it's helpful, and it will give me the motivation to make more of these. I'm going to try and complete this question paper in full. This is just so that I do understand what I should be I should be doing to improve the quality of my videos as I move forward. So thanks for watching. Do share this with your friends if you think that they're going to benefit from this. I am going to try and make the entire question papers for chemistry and bio for AS. At least I'll try to. Hopefully it works out. Thanks.